Imagine you flip a coin. It can land as heads or tails. But what if I told you that before it lands, while it's still spinning in the air, there's a moment when it is both heads and tails at the same time? This peculiar scenario mirrors what scientists observe when examining the smallest particles in the universe, such as electrons or photons. In the realm of quantum mechanics, the rules of everyday life do not apply. Particles exist in multiple states simultaneously, much like our spinning coin. This phenomenon, known as superposition, suggests that particles explore all possible paths until someone observes them to determine their actual location or state. Now, let's talk about the moment we stop that spinning coin, when we catch it in our hand. When we take that observational step, something truly fascinating happens. The quantum system, which existed in a haze of unlimited possibilities, suddenly collapses into one definite state based on our observation. Before we looked, everything was open and uncertain, but our act of observing is like the universe making up its mind about the particle's reality in that moment. This transition from haziness to definiteness is known as wave function collapse. You might wonder why this matters. Well, it challenges our ideas about how reality works. For a long time, we thought that things are definite and predictable, but quantum mechanics shows us a universe that's much more fluid and filled with possibilities until we look closer. The implications here are profound. Quantum theory suggests that reality isn't simply out there waiting to be perceived. Instead, conscious observation plays an active role in shaping and defining the outcomes we experience on tiny scales. Picture yourself in a lush garden, where paths branch off in every direction, each leading to a different, hidden part of the garden. At any point before you choose your path, all the possible routes exist for you simultaneously, offering a multitude of experiences. This garden of forking paths is a perfect metaphor for the quantum concept of superposition, where particles like electrons and photons aren't confined to a single route, but explore all potential paths at once. In this quantum garden, the particles weave through every conceivable trail, embodying every possible state they could be in. They are like explorers without a set destination, traversing every path until a moment of decision arrives. This moment comes when we decide to observe them, to see where they are or what they're doing. It's akin to us choosing a path in the garden and committing to it, revealing the journey's direction. But here's where the magic of the quantum world comes to life. Once we observe, once we choose our path in this quantum garden, all the other potential paths vanish, and the one we're observing becomes the reality. This transition is what scientists call wave function collapse. Before we look, the particles are free to explore every path, but observation locks them into just one, determining their state and position in the garden of reality. Why is this important, you might wonder? It challenges the classical view that the world operates in a straightforward, predictable manner. Instead, quantum mechanics reveals a universe brimming with possibilities, governed by the choices made when we decide to observe and interact with it. As we prepare to delve deeper into the mysteries of quantum mechanics, we'll explore how this act of observation doesn't just passively reveal what's there, but actively shapes the outcome. Continuing our journey through the quantum garden, we come to a profound juncture, the moment of choice, where numerous paths merge into a single definitive route. This moment is akin to what scientists call wave function collapse, a pivotal event where the quantum system, much like a traveler in our garden, selects its definitive route upon being observed. Strolling through this garden, the choice to follow a particular path, maybe lured by the fragrance of a flower or the whisper of leaves, narrows the vast possibilities into a singular, lived experience. In the quantum world, this mirrors the act of checking an electron's position or gauging a photon's polarization. Observing solidifies one potential state into the actual state, the chosen fork in the garden's path. Herein lies the garden's enchantment, reflective of the quantum realm's enigma, the observer effect. Our act of observing doesn't just reveal the path, it influences which path emerges. Just as the garden seems to answer to our presence by unveiling a path beneath our feet, quantum particles appear to decide their state through our observations. Think of it this way. If in our garden we had the power to make a flower bloom by simply looking at it, we'd be exercising a sort of observer effect. In the quantum garden, this is exactly what happens. The particle's state, its very reality, is influenced by the act of observation, aligning with the path we've chosen to explore. This interplay between observation and outcome challenges our conventional understanding of reality and causality. It suggests a universe where the fabric of reality is responsive to our interactions, where the mere act of observing weaves existence into a defined form. It's a notion both bewildering and magnificent, unveiling a universe more dynamic and interconnected than we could have ever conceived. Our role as observers is dynamic, actively shaping the reality we experience. The paths of quantum particles are not merely waiting to be discovered. They are engaged in a dance with our observations, co-creating the cosmos's existence. Now let's dive into a quintessential experiment in quantum mechanics, the double-slit experiment, which showcases the astonishing feature of wave-particle duality. Picture this. A couple of scientists direct light through two small, narrow slits, and then watch what unfolds on a screen positioned behind them. Contrary to the expectation of seeing two distinct patches of light, they observe a series of light and dark bands, forming a pattern resembling the peaks and troughs of ocean waves. This phenomenon, known aptly as interference, indicates that light doesn't merely travel in straight lines, but instead spreads out and overlaps like waves in a pond. The intrigue deepens when this experiment is repeated with particles such as electrons, which, despite being thought of as mere particles, also generate an interference pattern, behaving as though they're waves that spread and overlap. Now, here's where things get even more intriguing. When scientists decide to watch which slit each electron passes through, the wave behavior vanishes. Instead, the electrons act like particles again, hitting the screen in two distinct spots aligned with the slits. This shift in behavior due to observation is a clear display of the quantum world's odd nature. The double-slit experiment provides compelling evidence of the dual nature of quantum entities, which can exhibit both particle and wave characteristics. This duality is central to quantum mechanics and represents one of the most striking demonstrations of the unconventional and counterintuitive behaviors that define quantum weirdness. What does this experiment reveal about the nature of reality? Fundamentally, it suggests that the very nature of things at the quantum level is influenced by if they are being observed. The notion that merely observing can alter an outcome, that something can change simply because we looked at it, marks a radical shift from the classical deterministic view of the universe. This concept has transcended theoretical physics and influenced practical applications, notably in quantum computing, which leverages this strange behavior to process information in entirely new ways. It invites us to reevaluate our understanding of the universe's workings, proposing a more complex and dynamic relationship between the observer and the observed. In the deepest reaches of the quantum realm, we are not only discovering the laws that govern particles and waves, but also venturing into a vast garden of philosophical questions that challenge our very model of reality. Quantum mechanics, characterized by its inherent uncertainty, compels us to ponder deep questions. What is the true nature of reality? Are our lives determined by set patterns, or are they shaped by randomness? At the core of quantum mechanics is the principle of uncertainty, which shatters our naive assumption of living in a predictable, clockwork universe. Instead of a world with predetermined outcomes, we encounter a universe filled with probabilities, where outcomes become clear only when we observe them. This shift from determinism to a probability-driven reality invites us to reassess our place in the cosmos. Are we merely actors following a script authored by the laws of physics? Or are we active participants shaping our own existential narratives? This philosophical inquiry deepens when considering the role of consciousness in quantum mechanics. What does it reveal about the power of our minds and our perception of the world if merely observing an event can alter its outcome? The interaction between the observer and the observed blurs the accepted lines between subject and object, suggesting a universe that is not just out there, independent and indifferent, but one that is responsive in some way to our actions and awareness. Quantum uncertainty compels us to rethink fundamental concepts such as causality, time, and space. In a universe where particles across vast distances can be entangled, influencing the past from the future, our linear cause and effect understanding of time is challenged. What implications does this have for the flow of time, the sequence of events we call history, and our own experience of existence? These questions extend far beyond idle speculation for physicists. They strike at the very essence of what it means to be human, to seek understanding and meaning within the universe we inhabit. Quantum mechanics suggests viewing the world not as a rigidly deterministic machine, but as a dynamic tapestry of interconnected possibilities, a realm where our participation matters, where our choices and observations contribute to an ever-evolving cosmic narrative. Yet, the quantum journey doesn't end here. Beyond the mysteries we've explored, a landscape rich with further quantum enigmas awaits, such as spooky action at a distance, where entangled particles across the cosmos affect each other instantaneously, defying the conventional notion of space and time. These mysteries and more beckon us as we continue our quantum adventures. Each question leads to new discoveries, and each answer unfolds into new mysteries, fueling our quest to understand the universe and find our place within it. To dive deeper into stories like these, stories that chill the spine and stir the imagination, make sure to hit that like button. It helps more than you know. And don't forget to subscribe to Curio Wonders. Here we unravel the mysteries of the unexplained and the unknown. From haunted histories to enigmatic legends, our journey is endless, and we'd love for you to join us. Click that bell icon too, to get notified about our latest adventures into the shadows of our world's most intriguing mysteries. Thank you for watching, and remember, in the world of the strange and mysterious, there's always more to the story. Until next time, keep wondering, keep wandering, and keep exploring the depths of our fascinating world.